My name is Olaf Scheibner. I'm with Thermo Scientific and I'm product specialist for the X-Active Plus mass spectrometer. And on the poster back behind me, we show an application we ran on this new instrument. And basically this is an application of looking for pesticides and drugs and other unwanted components in horse feed or in animal feed. So if we take a look at it, first of all, we have here a schematic of the instrument. And as you can see, we have a couple new features in this instrument, compromising the S-lens, giving us higher ion transmission. And there we have just ion guides into the C-trap. So this is a screening instrument without precursor ion selection. But back to the application. What is run here is a basic standard application. So we have horse feed, which was extracted by the well-known Quetscher's method. And looking into what we did on the mass spectrometer, just a quick look into the mass spectrometric method, instrument method. And as you can see, this is a very simple method. So what we set up was a generic method. We didn't do any compound optimization or anything like that. We just decided for doing a full scan and a data-dependent fragmentation based upon an inclusion list of analytes we want to analyze in a targeted manner. If you go further, have a look at the LC method. This as well is a standard LC method. It's just a 5-minute UHPLC method with a very simple gradient made of water and acetonitrile, both containing 0.1% formic acid. So what I did here basically was just set up a very generic method, which I use for many applications of this type. Coming from the LC method, looking into the results we got, looking into this peak. So it's a 3-second wide peak, but still we get 13 scans across that peak, showing that this machine is fairly fast enough really to run short chromatographic gradients and to get good results from that. Looking a little bit further, look at the elution profiles we got from a selection of components. In total, we looked into 85 components. This is a selection of that, but all are giving nice sharp peaks, which are vastly overlaying. But anyways, on this instrument with a resolution of 70,000, it's not a problem to generate extracted ion chromatograms like that one here without any noise between that. So we have really nice separation, which is just as selective as you maybe used it from a triple quadrupole method. And you can see we got a very nice linear calibration curve. So we are really fit for quantification on these components in this complex matrix. To make things even more easy, we have ExactFinder software helping us to analyze all that in one run. And looking into this panel here, what we see is the results. We have a couple of samples here. We have our components we want to quantify or to analyze on. And then we go on, we see the peak fitting. We can see how well the isotopic pattern of the signal we measured fits into the theoretical scale, helping us to confirm our results on one shot. In addition, we can look onto fragments. You see in red and green that we have a couple of fragments shown here. And so we can, in the end, be very sure that we have the right component we are looking on, even without doing much effort in MS-MS. Another main thing is that we can really compare the isotopic pattern. And just look at this signal. And you will see in the green boxes the isotopic signals which are surrounded by matrix signals, really showing that the resolution of this instrument is capable of separating much higher matrix peaks from the analytes we want to look at. And this really helps us and ensures that we really can separate everything. The isotopic pattern is undisturbed and is absolutely reliable. And so we are coming up with a very fast and very reliable method to analyze whatever you want in whatever matrix. So here we had a quick walk through this poster. And if you want to know more about that, go to thermoscientific.com/ASMS to download this and to view more information about it. Thank you for watching me.